So yes, so okay, so yeah, we'll wait for another 2 minutes. Hi Binay, hi Shivam, hi Rahul, hi Mohammed Washim, um, hi Akriti, Ajay Kumar. Okay, looks like Siri has some issue. He'll be joining again. Just keep, yeah, he's back again. Siri, once you are able to hear me and able to speak, just let me know. So still settling down. Okay. So yeah. So we'll just waiting for Sree Sekhar who will be giving the session today. He's saying he has some trouble joining, so we'll wait for another 1 2 minutes. So he has some trouble. He's trying to sort that out. Give us a minute or two. I can see him. He has joined, but looks like he's not able to speak. Uh, But anyway, we'll start. Anyhow, we'll start. I will give you demo on how to claim your certificate, how to watch this session online, and other other tips. And then also I will give you the brief on what this session is and how to start on it till he join. So just give me another 1 minute. Let me help him sort that out. Sure, Dixon. So, Binay, can you hear the sound now? No, right? So we're still to start, Binay. Okay, Siri is trying to join again. In the meanwhile, what I will do is I will try to start the session. I have the slides. Let's give me a moment. And once he join, he will picking up from whatever from the middle. Slide is opening up. Give me another 1 minute now. It's almost done. Okay, guys. Will obviously once Siri join, he will be picking up from what I left. But let me start. So, are you guys able to see my screen? I
Yes.
believe yes. Okay. So yeah. So let me open up the slide and let me try presenting it. So you can see the whole screen now. Okay, cool. So yeah, so this session is more around building microservice and building microservice from the beginning, what the concept of microservice is. There's obviously basic session, starting session on microservice, but this covers a lot around. And Siri, whenever you join, you just ping me up. And this covers a lot around the base and the building block of microservice, why the need arises for microservice, and how we can handle that out, how we can build the application around microservice. So, as you know, this is a Martin Fowler quote, which start from building microservices is relatively easy. The more difficult part is everything that happens between the services in distributed systems. So it's more like a single human being is very easy, but when all the human being interact with each other to form a system is a big problem. So let's move on to the next slide. So we are just give me a moment. So we are a community of leaders who are actually involved in setting up the multi-cloud for you platform, which actually deals with all type of uh, uh, cloud transformation, cloud architecture, designing and defining cloud principle, and also building a holistic cloud solution that solves multiple problem and that actually is mixed with on a multi-cloud platform that can be hosted on a multi-cloud platform. We have another session on a frugal cloud solution, frugal cloud. Uh, Basically, that's more around frugal cloud storage tomorrow. But today's session is specific, generic to what we can implement on a distributed system is microservice. So uh, this is Sree Sekhar who will be who will be speaking on this topic today. Obviously, he had some issue with his machine. I believe he would be sorting that out, and he will sort that out until we come up through the agenda. But he is a technology strategist. He is a marketing technology leader, and he has 16 years of experience in IT industry across multiple industries, and we have seen him flourish on different talking to different. He's more like a architect who has a lot of a deeper client connect, trying to solutioning thing on a different perspective, mostly in the martech domain where there's a lot of load when the campaign runs, and therefore there's a different kind of architecture needed to solve that high load or at a precise time or a specific time, and that's where the challenges comes into architect hand. He's a senior architect at Razorfish, and this is LinkedIn profile, Sree Sekhar Palarpati, and this is picture. I think is in front of Massachusetts Institute of Technology, and I think it's a nice weather there. Obviously not these days. This is me, Anjani Kumar. I am in mentor, leader, mentor, founder, enabler. I have multi decades of direct service to the IT industry. I am ex-publicist, RBS. I work with Microsoft, multiple NGOs, government, and other in the past. I have not mentioned everything. It's a big deal to mention everything. You can connect to my link to my connect to my LinkedIn profile, which is Anjani K. Kumar. You'll find a lot about me, and I am the principal architect of multi-cloud for you, and also the founder. Uh, this is our though where we all the where we upload all our session is multicloudforyou.com, and you can create your account free, and if you're facing some issue, you can go to help and FAQ, which is there on the top of the website, as a help link. Uh, so we can subscribe our YouTube channel, and this is all the style of engineering where we have made it in a broken QR code. But still, if you try to scan from your mobile now, even it will work, and you'll be able to subscribe to our YouTube channel. Why are we doing this session? So our primary motivation are sharing of knowledge to build optimism, make more and more people aware on cloud, emerging technology, mostly technologies which are helping us transform from third, or basically partly the starting fourth industrial revolution to the high stage fourth industrial revolution, or high stage fifth industrial revolution. You can also watch my keynote on my website, homepage of the website, on what is the difference of fourth and fifth industrial revolution, and why it's important to gather together, brainstorm, learn together, and then move on into our career path. Obviously enhance the capacity of innovation, so that bringing more and more people aware of the technology, aware of the changing in the technology fast, and therefore we bring different architect who has actual real experience in the industry, not the trainers who are just coming out from taking up something from here and there and trying to speak out. There are people who are actually implementing, who are investing client money to implement it on the fly, on the ground, and they're facing the real challenge. Reciprocate what we have learned in the industry and lower the entry barriers of newcomers. So this is also for newcomers. So we actually help newcomer, mentor them out to join into the industry. That because that's where the actual pressure is. Uh, so agenda for today is overview, why microservice, MSA pattern, pitfalls, what's next, key takeaways, question and answer. But I will try to ask if Sree Sekhar join. Siri, if you joined, I believe still just give me a moment before I start. Uh, let's see if it's okay. So I'm continuing, and he can join. I'm just giving him a message so that once he. So he's saying he's saying for five. He's asking for 5 minutes. Looks like his laptop is doing some update, but no issues. I will continue, and then he will pick up once he joins. So agenda for today is overview. Why microservice? MSA patterns, pitfalls, what is next, key takeaways, question and answer. So overview is obviously microservice. When we talk about a distributed system, that there is some distributed system in place that we're going to talk about, we're going to discuss about, and and that's where the all story of microservice starts. So if you see this picture, you'll be able to find out multiple nodes. Nodes are what? Are computers. These are computers. So each and every node can be computer, and computer can be anything: handheld, desktop, IoT devices, and a lot many things. Wherever if there are chips and they are doing something on their own, if they have a compute power, they are computers, right? So each and every node that can work independently is computer. And the best thing is every node makes its own decision. So even a computer can be a Docker container. So it's like today the thought of being a computer, saying something a computer has changed. So even a single computer has lot many compartments, and they work differently, and those containers can work differently. Even the application that you are working, right? So that application that you're working on your machine, every application can be a single node. So in a single computer, multiple node can be there. or even a single computer will have single node based on the need, and that can be a decision making thing. So uh, that's the best thing about the node and the system. So every node makes its own decision, and the final behavior of the system is the aggregate of the decision of the individual node. So so now when each and every node correlate and connect together, talk together, and then the outcome is the accumulation of the decision done by every node, then we call it a real distributed system. And we'll give you multiple example during the path. So, but let's start from the from here. So why we're talking like this? So there are three type of system actually we when we start talking about, when we start thinking around, comes in our mind. The one is centralized, another is decentralized, and the third one is distributed system. If you see in the picture, so uh, centralized system, right? So Wikipedia is one example. Here you see that there is a one node, there is a server, and that's a master, and then there may be multiple computer using it, website or many application that looks that are stand alone. There's a server and there are multiple slaves for the client using it through browser and through multiple ways. The another one is, are you able to hear me, guys? Right? So am I audible, everyone?
Yes,
Okay, cool.
perfectly
Okay.
clear.
Okay, cool. And then the another system, obviously we have separate session on blockchains. Blockchain, there's a deep dive. You can go on our YouTube channel. You can talk. You can learn a lot about Arc. If you have any issues, you can start on Arc. We are the partner with Arc on the Arc exploration and how the Arc system works and how the Arc blockchain works. And then once you go there, watching our video, I have presented on Arc. Then you will be able to do a deep dive on blockchain. I have another team, Blockchain Kids, which is for meant for kids learning, which is specifically meant for blockchain. And my daughter, who is just 12 years old, is a blockchain kid, geek and speaker on blockchain. She's learning blockchain for the past 2 3 years, almost 3 years, more than 3 years, and she is nationally known and she has spoken on the multiple platform, multiple system. So blockchain, we keep on coming on and engaging people on different session. But blockchain is more around where different masters, right? So there are different masters which are there, and each master can sync the data between them securely. So that's the difference. Like there's one server, and then there are multiple client, and then when the blockchain comes, there are multiple servers, and each servers can have multiple client, and as one server can be a client for another server can be a client for one server. The way if you build your system in the beginning, or if you have tried building a TCP/IP based client server application, and if you just have tried to add up more and more nodes into it, where each TCP/IP node can act as a server and each server would connect to each other. Just try to think around that. But obviously, the best thing is our old days, when mostly I don't know everyone of what age group everyone is here on the in the session, but the people who have passed the age group of 34 or 35 and beyond, they must have used BitTorrent a lot. So BitTorrent was the initial example of what the distributed system and peer-to-peer system would look like. And then definitely came based on that technology. Obviously, there was a parallel research going on, and that was blockchain. So then the node computer, right? So node computer is, obviously it looks like decentralized, but still it's centralized. So all the nodes can compute, can do different things, but when the outcome comes out, is a cumulative outcome. So like the Google. So these are the example between centralized versus decentralized versus distributed system. And Siri, once you join, just yeah, just alert me. Because I am just trying to hijack you because you are not there. So, and I'm not able to see who has joined because I'm presenting at this point of time. So why distribute the system? So scalability, low latency, and fault tolerance. So scalability is distributed system enable horizontal scaling, thus reducing cost for large scale workload. So let's say there is one node, and the node is there is one application, and the application is much independent. It doesn't have uh, the it doesn't have the complexity of what we build with when you apply session or sticky session or do a lot of things. But still, if it has complexity, that complexity has been managed, and it's a single system which can be horizontally scaled up. So there, for the scaling, we have a different session. We have done it in the past, and if you go into the multi-cloud for you sessions, you will see there's a lot many description and a very detailed description on the scalability and how the scalability is performed on the cloud, elasticity, and what are the differences are, what are the different examples are, uh, and you can go and learn from there. Uh, I have also given my co-partner and multiple speakers has given, and most of the sessions are there. Pre-recorded sessions are there. So distributed system enable horizontal scaling. Horizontal scaling is something like, think about uh, a matchbox. One matchbox is there, and that's one system. And let's say if you have to scale it up, the one thing is that you either make the matchbox bigger. That's vertical scalability. But if you try to make a copy of the matchbox, that's horizontal scalability. So distributed system, the best thing about them is you just need to have only one copy of the system at one point of time. You can have one copy of system running, multiple nodes running with one copy of the system. But once the load increases, you can have multiple copy on the fly. Low latency, distributed system allowed to have nodes in various geography, allowing traffic to hit the node that is closest. So you can have multiple nodes, same copy of application working in different geography. And if you're trying to use it from the USA, you will the client, when try to hit the node, will automatically it will get routed to the USA node. If you're trying to hit it from India, it will get routed to the India node, and they all are being synced in the back. There are different way to sync. We'll definitely come together in our most of our database sessions. There's another session on a very deep dive on database and how big cloud system manage uh, those data syncing capability in the background, how they handle uh, millions of load per second. Fault tolerance: a cluster of 10 machine cross two data center is inherently more fault tolerant than a single machine. So saying that a cluster of 10 machines across two data center is inherently more fault tolerant than a single machine. So let's say there are 10 machines and they are kept in data center, means there's one house where multiple machine is hosted. There's another house somewhere where multiple machine is hosted. One data center, another house, another data center. Just consider it like this. Obviously, I'm not going diving deep into the cloud terminologies, but try to understand at a high level. The data center is, there's a one house where there is electricity, there is network, everything is being supplied in ample proportion, and then there are multiple computers connected to each other sitting there, one data center, right? If you do a copy of the of one of one such pack, it becomes a zone, and if it's miles apart, it becomes data center, or geography apart, it becomes a data center. But that's another part of discussion. So a cluster of 10 machine across two data centers is inherently more fault tolerant than a single machine. So I have a single machine, I'm running something on a single machine. If it fails, it fails. But if there are multiple copy of the same application running on multiple machine and they sync together, if four of the machine fails, still my system would work. So that's what it's saying. Siri, did you join? Still he is uh, so what we'll do is, like, I'm continuing this session, and I will reschedule the session uh, for Siri again, uh, maybe in the next week. So But monolith versus microservice, you can see monolith is like you build some application X and you have multiple, like when you build it into a single program, single application, the website today, many website that you build is packed, a portal is packed with all the application running inside it, all the DLLs running inside it. That's a monolith. And a microservices, obviously it looks as a single application at the front, but there are multiple small nodes running in the background. Each node working, doing some specific task, doing some single task. And each node, when they do some single task, when they connect together, they talk together, they become a system. And that's called microservice. So you see, you so you can see there's a big icy here, chocolatey here. It's a monolith. I think someone mic is not on mute. Let me give me a moment. Okay, so just me. Okay, so the one at the side, which is a bigger one, a bigger dumpy, is obviously monolith, and the one which is doing minute work but is still able to do the complete work is the example of microservice. So this is one example of a monolith versus microservice. In a monolith, you have a user interface, the website, the web page that looks like. Then you have a business logic where you write most of your code, if else, if if something happens, do something, if something happens, do that thing, blah blah blah. And then once you do your business logic, you have a data access layer which is called dial, and that does connect to database. Okay, so that's the basic monolith which is there, and that's mostly being used in the industry. Whenever you try to build something, you will use this model because it's more simple to work, and and it works fine today also. But when you have to manage a big application, when you have to manage all of a sudden a huge load, when you have to manage multiple things in the background, it's not possible and not it's not easy always to play with monolith, deal with monolith, because once it becomes mammoth because you start writing code at the beginning, it looks very easy to build a monolith because it's just as a user interface, a business logic, data access layer, and the database, simple. But once you keep on adding modules and next module and the next module, so if uh, so if I think someone is not on mute. If you can go on mute, that would be great. And so there are multiple layers that keeps on coming, and then the connectivity becomes an issue. Developer leaves the organization, some new developer comes in. He will not understand the what the last developer did. Even if he gets KT, he will not get a context of one past 1 year in 2 months, 3 months. He will try to do something on his own. He will try to fix that up. There will be more issues, bugs, and that keeps on happening in a monolith world. And we have been doing it for the past years and years. But now, in the past 7, 8 years, I would say, it's almost 7, 8 years or more than that. Obviously, these systems were there from the past also, but they were more like architected architect based on the architecture need or the product need. But now they have become as a standard, de facto a standard to build system. So it has a user interface. There is a microservice. I say it as a mega service, right? So there is a mega service or a little heavier service at the front, which is mostly using that service. And and then there are multiple microservices in the background connected to different DBs, database. Even there is no database, even the file can be in the JSON, big data, or anywhere. So and then connected to the different DB, and then these DB is able to do, like, each microservice is able to do independent work. So they are completely disconnected from one another, and when they interact at the microservice layer. So everything is happening at the microservice layer. database is their own. It's like a husband-wife relationship, you can understand. Microservice is the husband, database is the wife. So one husband and one wife, like it's a one-to-one relationship. They're not going to do polygamy. So if someone has to talk, one microservice has to talk, he has to talk to the other husband microservice. He's not going to talk to the database of other microservice directly. That's a de facto gender, but that also depend upon how you architect, how you define and design thing, how much budget you have, what is the load you have, and how are you going to do it. But that's something. This is more a cleaner architecture and experience, or the one which people want to follow. There's the whole concept is used. This cannot be covered in a day. So it's just the beginning kind of architecture that I'm placing here. But if you start diving deep in the coming sessions, you will see that how these things get complex based on network uses, when the containers, when Kubernetes comes into the picture, how their hosting becomes complex, how their fault tolerance become complex, how their sidecar capabilities become complex, and how logging, and there are multiple things, how the transaction become complex, what is Saga and all. We'll definitely go through that, even if giving you hands-on down the line. But this is more around the basic understanding the concept around microservice. So why? So if you try to memorize this picture, the monolith is user interface, business logic, data access layer, and database. Right here, database can be used by different modules. Like one data access layer is there. There are multiple different modules. There can be multiple DLL. There can be multiple EXE that you are using it. Right. There is no one-to-one relationship. So it's something I'm not able to speak at this point of time. This database is a different kind of thing, right? What we understand in normal language. But if you talk about microservice, user interface, microservice, then each microservice has its own database, and that database is not interacting with other database directly. Obviously, there are multiple mm, go charge to it, and there are multiple things also moves on need base. There may be synchronization that may be happening, and there may be read only copies may be created based on the need, because again, optimization and cost is one of the biggest factor to define uh, your architecture. But this is the basic structure. Try to, like, when you try to define the system, try to see that if you are able to define the system in this way or not. If you're not able to define the system, obviously there may be how much flexibility you are doing. But again, that's again the against the rule of engineering at the first, and then you must have uh, a reason for it and why you are doing it, and everyone in your team, if he agrees, then obviously there must be a reason for it. But this is the first thing to start with. Each microservice has its own DB, and then this main microservice can be connected through another microservice, or this can work as a coordinator. This can work as someone who is trying to tell that this microservice is alive or not. So if the user interface is trying to say that I have to do some checkout work, then this microservice 3, which is there here, can do the checkout work. If say that I have to do some registration work, microservice 2 can do the registration work. So this microservice can just become an informer for different user interface to tell that, okay, where do we need to go? This is the guy where I need to go for registration. This is the guy where you need to go for checkout. This is the guy where you need to check your order. This simple e-commerce funda. So one um, going for the order, another for going for the registration, another for login, and then the third one, fourth one for adding to cart or product display, and that's all. And there are multiple things that comes into the picture. Then why microservice? So there the benefits and value proposition I'll be talking here. So see, digital transformation enabler. Siri, I would say, because I'm trying to explain his slide. If you would have been here, that would have been fantastic. But having worked in the industry in a similar domain with him, I can understand his emotions. So digital transformation enabler, when he says that digital transformation enablers, currently the industry is going through a layer of transformation, and we call it a digital transformation at one point of time, because whatever it was there, in the last 10 years, 15 years, during the dot-com bubble and bust, and then things got stabilized. Now it has changed with the time. The software and the system which were there, the strategy which are there are changing. So there's a complete transformation happening into the industry. Obviously, we'll set up another session on how what exactly digital transformation is, where we are, where the possibilities are, and what else we can explain around that. But at this point of time, we have to understand that digital transformation, one of the reason for digital transformation is how you can optimize the digital space or digital uses of the company. And start from digital marketing. It start from the adoption within the system, uh, uh, among the client, among the different touch point of a system or a company, and the experience around it. Either you go into the store, come out from the store, how you interact with your customer. Everywhere there's a need of digital transformation is happening. If you see in the Indian government world in the past 4 or 5 years, uh, how the NIC website would use to look like, and now mygov.in, there are multiple services, and how fast now the government has become that within 1 month there was an app that was live for Corona. So that's where the engagement in, that's where the enablement is. Unless and until you do not enable things at the different layer, it's not going to happen. And obviously this happens because it has a need, and it's also has to be done. But every change has an emotional journey from a different perspective. The people who are trying to who are involved in doing that change, the people who are already working in some different style, and now they are being asked to change. There are a lot of things, lot of colors to it on the same term, and even one can speak half an hour, but obviously this is not the agenda of the session. Just simply so you can understand that it's an emotional journey, and it's something when you try to change, it's
Hey,
going
Anthony.
through bubbles and bust. Yeah, Siri, you are here, right? So, yeah.
Yeah, finally, like after 20 times. Sorry about that, guys, everyone.
No issues. So you
Yeah,
can
so I
start from
think
here. So
you
because
already.
yeah, I've already given them a background of microservice, and you can start from here. Everyone is
Okay.
like eager to hear from you. Yeah. And guys, just wait. So we'll
Sure. So for
announce
that,
the code, participant code, once the session ends, or maybe just 5 7 minutes. How many time we have left? Like we have 4 5 slides more, and we'll announce the session around. And now we'll announce the speaker code which you can take to get the certificate. We'll give you the link also. Yes, sir.
yeah. Anjali, so I don't know if it would be justifying to do all this in 5 minutes, but actually the slides also have changed. Is it okay to reschedule this or to, because I know we have very short time to finish off
I think
everything?
I think we can have a couple of sessions, but at least we have another 20 minutes, and we can try whatever is possible, and
Oh,
then
we you
maybe
have 20 minutes?
yeah, yeah,
Okay. So maybe let me share my screen and quickly
yeah. So
we can get
I'm making
started
you
with
the
that.
presenter. I was sharing my screen,
Okay.
so let me make you the presenter.
Let me know if you guys are able to see it.
So are you able to share your screen? Still not change role to okay. Are you able to share
It
your screen,
says,
Sri?
yeah, it says I'm sharing my screen.
Okay, I'm changing you to host. Try to okay, no. If you sign the host role, the person have control cancel. Okay. Okay, yeah, I can
Are
see.
you able to see?
Uh,
Okay.
Starting to sharing
Okay.
content. It says yes, yes. We are able to see. Good.
Okay. Cool. So I will not take much of time in the introduction since, like Anjani has already gone through the entire introduction and brief on a high level. First of all, I would like to apologize for the technical difficulties and I couldn't join. But yeah, we will be going quickly through the rest of the decks that we have mentioned here. So I think we have looked at the microservices overall, like why we are using it, and it has a value proposition to it. Why businesses need to adopt this culture to become more agile. We have been talking about every business is focused on releasing things quickly, fast to the production, and we know that the recent businesses, I mean, not just recently, but it has been now for a decade time. I would say that the clouds and DevOps space has evolved a lot, but with the microservices actually would be another I would say arsenal which businesses would need for have that agility, and it also has the value of scaling independently these services so that you could launch specific features and focus on specific functionalities which can be scaled, which are only required instead of scaling the entire whole application as in the case of monoliths, and also having quickly be able to respond to any faults which are there in the system and not bringing down the entire system down, right? So these microservices approach provides that ability to have that granular control over your entire application and features. Again, as we know that there are like no silver bullets in technology, as we all know, this I think applies to most of the concepts that keep coming over the time. But definitely, if you give this tool to a kid, in this case, like he's just depicting it as a toy, where you give microservices to a business and they are not ready to adopt it, so it would not be a success story. I mean, so definitely these are not silver bullets. There is art involved. There is a lot of study involved in how do we adopt these type of concepts in any businesses. So I think that brings to this section of patterns. Patterns are always important. We always know that, like, why do we use patterns across in any of the areas that we do use in our software development, and microservices no different. And once any business starts to adopt these microservices without a proper strategy, these could grow like quickly within no time, and without understanding all the patterns and which need to be thought through thoroughly before adopting that, it would be definitely landing into this zone, like which we would say transformation of a hell, right? Like, so we have heard the term like monolithic hell, but I think definitely there is a term out there called microservices hell as well, like which looks like to the right hand side. Sorry, I'm hearing some echo, but anyways, so yeah, so we definitely do not want to transform the bad side of the things, but definitely we need to enable the business to move more faster. I think to let's take quick look at the microservice in a unit itself. What exactly this composes of? It's definitely a service definition is like it should be independently deployable component in itself. That's the main concept that we are breaking the monolith into this thing. But what makes it more stronger, or the concept of microservice becomes more powerful by through the API concept. Like how does that microservice actually provides that functionality to the outer world, and using those APIs, there are mechanisms of which we call operations, which we usually expose, and which are of two types. I would broadly put them into is like one are called commands, which usually are like for updating your system, or like your backend systems, or to have make some changes to the state of the microservice itself or to the overall application. We call them as commands. And the second type of operations are called queries, which are specifically just, hey, give me the status of this claim, or give me that insurance number, or whatever be the domain be. That there are only read-only operations which are being categorized as query operations. Now, the clients using this microservice can communicate in synchronous way using REST or gRPC or any of the protocols which are there. But over the time, what is getting more traction is the asynchronous messaging. The way I would see this is like the external communication for the microservices, like when all the set of microservices in your application are communicating to the clients, those could be designed in a synchronous way, but the internal communication amongst the microservices is more important, and which is actually the complex part, which is more now being need to be thought through for a asynchronous way of designing. And we'll look at some patterns in down in the below slides. But asynchronous messaging is another way through these microservices can communicate with each other. And apart from the APIs and operations that we have looked at, there are continuously there is the ability for these microservices to push events and publish events to like a event publisher. We could think of it as like a message broker, or like event backbone, or any of those terms. But there is the ability that we need to that each microservice could publish these events to the event publisher, which would then it's another mechanism. Instead of APIs, we could also communicate amongst each of the microservices through the events. And similarly, as it exposes the API to do the operations, it also has the ability to communicate with other microservices through the APIs by invoking operations and getting some information, quick information from other microservices to process the data. And similarly, on the other side of the things, it could subscribe to the events as well. As it does publish some events, it can also subscribe to the other microservices events. And usually by design, each microservice, I mean, this is not a necessity or it's not like a mandatory requirement, but there is a concept of having a database per service. This is again like one way of doing state management within the microservice, but you could actually there are concept of thinking of how do you manage stateless microservices and handling it through different mechanisms as well. But usually you would like to design like some sort of persistence. Usually the trend is that the NoSQL databases are used for uh, storing a lot of like a verbose data for that microservice to remember, instead of having it like a traditional relational model. And one example, if you would think of like if you are storing an order information, like you would like to also store the customer information so that you don't need to go to the customer microservice and get that every time. So you could think of storing the JSON structures itself in the NoSQL instead of going to external databases or to the other microservices to return the data. So that's why you plan for having some certain level of persistence within for this microservices. And again, like given as we have seen the definition, microservices independent component, it needs to be deployable in its own. So somebody, I mean, this is a old from an old book called Microservices and Containers, written by I don't know if some Indian author, but he terms it as a marriage made in heaven. I mean, you could think of like definitely Docker things like Docker containers and like deploying the microservices in them gives that ability to make it as independent as it could get, and you could not think of like any more creating more dependencies in the deployment as such. So usually these two concepts go well together. But again, there is a case study where this is not the case, which actually proves that it's not like a mandatory requirement that you need to have containers, but it's a best practice. So Weatherberg, like they have implemented microservices like some time back, even before the containers, Docker, and everything has taken too much traction. So they have decomposed their microservices in such a way that they are able to still to date manage their microservices without using containers. So I think, yeah, it's not mandatory, but definitely you see as if you are starting with microservices, you tend to think of containers concept as well, like so that you can make the deployment quicker. Coming to that decomposition patterns, there are again like it's all about like the art, as I was mentioning earlier. There are a lot of ways that you could decompose a monolith into microservices, but the reason I highlighted the strangler pattern is because most of us could relate this pattern to the real world scenarios. Usually, when I work with clients, like definitely when they talk about microservices, they already they already have some sort of monolith application existing within the organization. So it's definitely not like a lift and shift where you would be replacing monolith one day and having all microservices all over the place. So this pattern basically describes of how you introduce those microservices, like by either building new features, or you basically divide the capabilities incrementally and then get rid of the monolith then instead of going feature wise. Like you can't start, like if there is a monolith, you can't start identifying all the functional areas and identifying the list of microservices to start with and then build those microservices and replace monolith. It doesn't happen that way. The migration needs to be following a certain strategy. One other pattern which is which is key to microservices concept is the integration pattern, which is basically the way the clients communicate with these microservices. API gateways have been there in the market like for more like I think it's everything. This concept itself is like a decade old, but things have been evolving over the time. But think companies like APG has been the leaders in the space of API gateway, which basically provides an capability of having a centralized place to control the API's calls. It's like it basically takes all the cross-cutting concerns into one place and have clients just call one API gateway so that they don't need to know how many microservices are sitting underneath it, right? So you provide the protocol which is needs to be configured, and then you have the API gateway handle rest of the routings and everything of that nature. So in this pattern, what we're seeing is like there is a unified protocol for all clients. So if you are building a web application or a mobile application, they all need to communicate with certain particular protocol which will be configured within the API gateway. And then downstream, the API gateway has the ability to maybe change some of the protocols, transform the protocols, and call the underlying microservices. But here in this pattern, you actually have the clients using a single protocol for interacting the services. And it also introduces a single point of entry. Like if there is, for some reason, there are ways again to handle this, but this becomes a single point of failure as well. API gateway could be the one point, because if all clients are, if API gateway goes down, then all your clients will not be functioning. So that introduces a single point of entry and failure. So the new pattern or a variation of that API gateway is called Backend for Frontend, which is becoming more popular, and people are adopting this along with the another trending pattern at the front end, which is called micro front ends, which is coming. Which has been there like for a few years now, but it basically talks about adapting the microservices concept to the front end frameworks. So you don't build a web application or a mobile application. You build a composite UI and break down the UI monolith into microservices. So that's a different topic altogether. But in that space of micro front ends, the backend for front end is also becoming more popular, where you introduce it as, think of it like a API gateway for each channel. You have in this pattern, what you have the ability is to basically have the introduce like uh, different protocols could be configured for each channel. Like in instance for mobile applications, you need just the lightweight data in the calls. You don't need coming from the back end to front end. So you could actually use something like GraphQL protocol. And for web, you could use the REST API, or it gives that ability to break down the protocols at each channel. So that's the variation of the uh, API gateway pattern, which is called backend for front. I think before talking about the service discovery pattern, I just want to give, like, I know most of us might have heard and know the concept of service discovery, but in case of microservices, definitely the service discovery is key or important because of the nature of the dynamic allocation of these microservices. These are being deployed into either a Amazon like EC2 instances and so on and so forth, and there is auto scaling in picture. So that your microservices can scale automatically. So they are dynamically being assigned some microservices. If they are shut down, they are not available in that same URL or the port that is configured earlier, and so on and so forth. So there is a lot of dynamism as compared to the static, like monolith server client server model. So definitely there is a need for identifying the API gateway or the backend for frontend that we saw earlier. They need to know exactly where to go and which service to call, where to call. They need to have that configuration being maintained constant. That happens with the concept called service discovery, which basically can be implemented using some of the tools out there in the market, which we'll see here in this slide. So there are two ways to handle the service discovery. One is at the client side, which is basically you could implement the clients to be aware of what the where the service registry is, and what are the clients that have registered within that service registry, which is available, what to call, and all that. And the client will then get a URL, then it can call it by based on the load balancing request that it gets from the service registry. So it could happen at the client side, and the other approach is to do it at the server side. There is no, I mean, one wrong way or the right way. There are scenarios which fit into client side discovery and server side discovery. There are implementations which are based on the need basis. I think the more popular ones is becoming slowly towards the server side service discovery, where you implement like the a concept of router, which basically introduces another layer of on the server side, which does the all job. Client side becomes lighter. It doesn't need to actually have the logic of figuring out which service to call, which endpoint to call. It just sit on to router, and it takes care of doing the service things. So these are two the patterns which are being used for the service discovery. I think shifting gears from the patterns a little bit on the concept of event-driven architecture, which is being thrown out there a lot. I think this has been there as well, like for a few years, as along with the microservices architecture, but it evolved over the time. I think the maturity around this concept is definitely changed within past few years. Earlier, there were event notifications, there were event broker, there was ESB, there was like a lot of stuff which is going on, and everybody were terming their own understanding of what event-driven architecture is, and then mixing it up with the microservices concept. So there is definitely to learn or understand clearly what exactly event-driven architecture fits into the microservices world.
Siri,
So basically, uh, are we short on the time, Anthony?
can you hear me?
Yeah, I can hear you.
Yeah, yeah. So, yeah, we just wanted to check the audience, like how much time they can have more. But anyway, how much time would it take to
Oh,
finish? Like,
sorry.
let's say, uh, are you able to hear me now?
I can I can skim through in like another 10 minutes.
Okay, so I believe audience would be able to bear with us for another 10 minutes. I think that's okay, just 10 minutes. And I will, after 5 minutes, we'll announce for the certificate. So yeah. So good, Mohammed Wasim.
Okay, sure.
So
Okay,
Anthony,
Yeah.
personally, I am here till it ends. So at least I have enough time.
that's
I don't
great.
know about
That's great. That's
others.
great. Yeah, thanks. That's the spirit. Thank you. Thanks a lot. Yeah.
Okay.
Yeah,
Yeah.
it was just
So
to check your mood, and then I think we would have broken it into multiple sessions. But anyway, if everyone is okay, then yeah, that's great. Yeah, we'll announce the
okay.
certification links and detail after 5-7 minutes. Yeah.
Okay, cool. Thanks, Jimmy. Yeah, so I think a little bit on the concept of like earlier, if you think about it, everybody is more focused on storing data into databases and having managed the state across services, applications through data bases, and data was in the center of everything that we used to do, and which is slowly shifting towards events being at the center, and data is actually all over the place, like it is flying. And there is that is why we keep talking about consistency, eventual consistency, which means that it need not everything need not be perfect. Like if you call from a bank mobile app, like saying that check, like deposit my check, it just does like okay, done. It just sends a message asynchronously. It is not actually doing the process behind the scenes. It just sends that message back, but the data is still in flight. Like there is a lot of data that is going and processing, and things happening at the back end. So the shift is focusing more towards managing, centralizing the events and storing the events, and then orchestrating the application state through the data in flight. So that is a shift. That is why we talk about event-driven architecture in the microservices world, especially when you are talking about managing designing your microservices asynchronously and communication between them, right? So this I will skip, quickly talk about this slide is showing about how the internal communication between the microservices could be an hybrid approach, like where you would be leveraging both APIs and events. It doesn't mean like you shift completely to events and not take advantage of APIs, because the APIs are definitely useful for any, like if you wanted a synchronous way of getting data from other microservices, you would be able to still leverage, call the APIs which microservices expose and get it. But for any like asynchronous mechanism of messaging between microservices, event should be considered through a infrastructure like a event backbone. We can quickly look at one pattern, which is kind of, it looks complicated. It is basically called a Saga orchestration, which is again, there are multiple patterns in the Saga way of doing things as well, but this one particularly gives one example of how we could implement something like using Apache Kafka or RabbitMQ kind of infrastructures to as an event backbone, and how you can manage the communication between each of these services. So you see there are subscribe concept going on here, like where order service is subscribing to most of the messages in the event backbone, and there is a like a sequence of dependencies which are happening in here from the message A to E. And you could actually think of concepts like queues, topics, which are coming up, to implement this as well, to manage the delivery of these messages which are coming from the services, and how these messages should be passed on to the other microservices which need to communicate. So I won't actually go into the more details of this particular slide in the interest of time, but there is a lot of interesting articles out there which explain this out, which we could take a look at it. And this basically shows another variation of communication pattern, again using topics and queues, where you would be, there are advantages of using only topics and only queues, but I think the more shift is happening towards taking a look at hybrid approach, like in many other cases, to leverage both, so that you could actually enable the scalability of the underlying microservices and not make them bottleneck due to infrastructure, like things like queues. You don't want to design for asynchronous communication and have some blockages in between in your system during the communication, because queues are point to point, and they deliver like the messages in a different fashion than topic does, where you subscribe to the topic and then it basically delivers all of the messages to it. So you could basically take a combo of these two and design it in such a way that the microservices are getting the best of both worlds, and you could still allow the scaling of the subscribing microservices events. I think we talked about containers, and there is a need definitely to uh, uh, push the responsibility of managing those containers to a different place than to the microservices. You want to keep the microservices to just to manage the um, functionality, the business logic, and everything, and you want to actually have the deployment things pushed to the other tools or like which could take care of it. Which is there are multiple things that you could think of is like a centralized configuration. You could think of like other patterns which are like sidecar pattern, which you could design for microservices and everything, which basically takes off that responsibility of how the deployment management has to happen for these microservices. So there are tools out there, like not just these three, but I just had to I just want to give a comparison view of these three tools which are out there for managing those container orchestrations. I think quickly on the pitfalls, definitely cross-cutting concerns is something which we usually tend to see put is put later on in the game. Like we just start off with the implementation and then we think about let's now start the performance testing or whatever. Like, oh, now we build the application. Let's see how it performs. So let's not go in that route for even for microservices, especially for microservices. I would say the complexity that it adds, this architecture adds, is tremendous in the way of the communication, as we have seen some of the slides earlier. And you can think of these cross-cutting concepts like something like logging. You have to basically design each microservices so that there is a connecting link between all of these microservices at some point, or like any messages that come out, they call it as correlation ID, so that there is a connection between all the logging which is happening, because these are all independent microservices, right? Like, so they would log their context, whatever in their boundary is, they would only log that material, and there has to be some mechanism that each of these microservices are connected somehow within the log, so that you could do aggregation of logging and monitoring, and using all this bunch of tools which are listed out there. Again, each one of those tools in themselves introduce complexity, because every tool comes with its own syntax, its own way to configure, setup, and all these things. So you could imagine how that slowly starts building up into the complexity zone of skill set of the team members, and like how the team should be spread to do something like this. But definitely this planning has to be upfront, even before you actually write the first line of the code in the microservices space. So definitely I would recommend like this to think about versioning of microservices, APIs, and so on and so forth. Failing fast, this is not like, I mean, people might have different understanding of failing fast is not to make the microservices fail. It is basically need to identify in the chain, because microservices are being communicating. There is a lot of chatting going on internally. There has to be a mechanism built in the architecture to identify what happens. Like, you have to assume everything and anything can go down at any point of time. And yeah, I don't know if how many of you have heard about the Netflix chaos monkey. It's a mechanism to actually, what Netflix does is they deliberately go and kill one of the like microservices in their underlying architecture, and they still manage the entire orchestration between other microservices to not fail the application itself. So every now and then they configure to kill some random service, but still their system is maintained. So they test for that type of resiliency of the system. So I mean, that in itself is like a whole complex, very advanced, I would say, of managing the microservices architecture, is to think about chaos engineering and that concept. But to start with, at least we should think of fault tolerance and resiliency, right? That should be in our mind. Usually, pitfall is like we don't think of these things. We think that, oh, these are like complicated. When we have thousands of microservices, will think about it, or some sort of that thing. But even if you are designing like for few microservices, you can your network connection any between on any of those microservices, or the microservices logic itself, everything can go down. So definitely design it for having stateful retry.
Hey Siri, we lost your audio. Trying to connect with him. Yeah, just wait. Can you hear me, guys? Yeah, informing him. Can you hear me, guys? Yeah, Siri, we lost your voice. Can you try it? It's like your mouse is mute or something. Mic is mute, or can you check? Yeah,
The serverless concept. So this is again coming up, like to think about serverless design for everywhere possible. But I would say that the key driver for thinking of serverless would be when your automatic scaling and low runtime costs are very important to you. You want really quick things to happen on low cost and things of that nature. So case to case basis, we have to consider serverless. So it's not one or the other. We have to think about where does the normal microservices apply and where you need to have serverless. So just be cautious of not just driving that. Oh, serverless is the new concept. Let's design the architecture in that serverless way, and just take taken by that. So something to watch while you're considering services. I think we rushed through a lot of content. I know I would love to actually have a broader session, but I think we, because of the technical difficulties, we are able to end this one. But just want to say end the presentation by saying that definitely strategize your migration approach if you are moving from monolith to microservices, and there has to be certain assessment of maturity of what culture already exists within an organization for adopting cloud and DevOps. If somebody is not uh, very new to DevOps culture, or what tools are being used and everything, they're very new to the skill set. Introducing microservices would be like throwing another boulder on their heads, like, because it'll just introduce complexity and make things chaos. So make sure that there is certain level of assessment done on the maturity level of the organization. And patterns, definitely, as we have seen some of them very quickly, need to be knowledgeable about adopting microservices to any organization. So definitely I would recommend everyone to be aware and be educated about all the patterns that are need to be considered for designing microservice architecture. And one of the element is cross-cutting concerns. Design it for those upfront and think about tools, skill set, how to divide teams, everything together. And let's not introduce this role in any of the organization called chief progress inhibitor, which basically he would easily be able to say that, okay, I don't need to do anything because you build microservices in your architecture. So that would itself pay for it. So so let's not introduce that role in any of the organizations. So be led by guiding the technology leaders and business leaders to take right decisions. in this area. Okay, so I think I did a very fast session on this one, but I really thanks for staying late on this call and extending the time. But I apologize again for the technical difficulties.
Yeah,
Over to
and
you,
can you
Anjani.
hear me, Siri?
Thanks.
Yeah.
Okay, so guys, here's the link. Sorry and apologies for I think this technical glitches happen sometime. If you can see my screen, uh, you guys are able to see my screen, right?
Yes,
Okay,
we
so
can see that.
yeah. So just go to HTTPS www. I think will give you a easy link. There is a streams dot. So there are two links. Both directs to same where streams.multicloudforyou.com. Here also session is happening, but there was some glitch here. We're still trying to resolve that out because of the lockdown. Our server has some issues, and that keeps on happening on or often. But anyway, we'll re-record and replay the session just after it. So anyone who missed, he can join. So here you go, streams.multicloud for you, or you can go to fifthir.com. The same link, fifthir.com. So it's easy to type 5thir.com, and then you just have to give your name, phone number, email. Put your name, anything. Uh, Obviously, you have to put the right thing. I'm giving an example, simply at the rate xyz.com. And then once you go here, check it out. And then once you go here, this is the code. So code is in the caps. So just try to here, just give me a moment. The code is MCS. Yeah, MCS. MCS. Is in the caps. M, M for Mumbai, C for college, S for school. All together, MCS.
And Jenny, we are not, yeah, see that URL which you mentioned.
Okay, so are you able to see my screen?
I think there is a current logo at the display which is multi-cloud for you. Nothing.
But okay, you are not able to see my screen. Okay, let me share it again.
I think Sree is the I think
Yeah,
Sree is the
can
still
you
the
see my
presenting.
screen? Can you see my screen?
Now, yeah, now I can see there is a pond and then ducks.
Okay, and
Is
now?
that?
Yeah, this is the URL.
Yeah.
Streams.multicloud for you, or simply 5thir.com.
Right, all right.
Just try there, go. Are you able to go there?
Yes, Anjani,
Yeah.
it's there.
So,
It's
yeah.
asking
So
for
then put
name.
your name, phone number, email.
Name, name, yes, and then accept terms
Yeah.
and conditions. Then it asks for code, and you said MCS.
MCS.
Yep.
And done. You should
Submit.
get that in your email. And this is our self-sponsored session. So tomorrow's session during the day is Alibaba sponsored. So we also give Alibaba cloud vouchers on those Alibaba specific session. So we'll also with this certificate we'll also give the free training voucher from Alibaba Cloud worth rupee 20, 10, 20, some are $50 also. So that's completely free. You can take certification, give exam, and take the session. So that will for the people who join tomorrow will get those vouchers. But for today, this certificate we're trying to add up more thing into it for more fun to happen. So yeah, so code MCS, M in caps, C in caps, S in caps. And if you don't get the certificate, you can try it again, or you can ping me on. There is a Telegram link, Telegram channel here. You see at the bottom. You can join this Telegram channel, ping us. If you would have joined, because we also take a capture of a screenshot, we'll definitely give you this uh, uh, that code. I believe people would have started getting it out.
Yeah, I think we will get it. So, but Anjali, this I mean, for the newcomers like me in the space of cloud, this was a very a fruitful session, and look
Yeah,
forward
yeah,
to
I can see,
multi-more.
I can see three people have already requested a session, requested a certificate, and obviously more to come. Yeah, thank you. Yeah, obviously it is too late. Else we would have opened up the Q&A session. Ideally, it's there. There was glitch with the series machine, and then I had to start a little late, and then so we did a mixed kind of session. But anyway, we'll rearrange this session in the future. I'll make sure that it does not happen. But anyway, if you have any question, you can still ask. Siri is still there, right, Siri?
Yeah, I'm still there. Yeah.
Yeah. So if you have any question, any specific issues, you can ask.
Uh, I mean, if you can recommend certain training courses on this, that would be good, so that at least I
So
can start learning it.
microservice, obviously, where Siri
Yeah,
says,
I
right?
can definitely.
Yeah, Siri will. Yeah, Siri, please.
No, go ahead, Anjani. Yeah.
No, no, you continue. I will add up one minute.
Yeah, I was just saying I would I mean as there are bunch of definitely trainings out there, but the one site I would definitely recommend to read around patterns, especially to understand the concept, is Chris Richardson. His name is very famous in this space. I think you got to definitely go to the microservices.io site. Um, he has like
Let
spoken
me
in
type it.
multiple events, which you
So let me type it
yeah
also, right?
I am.
Micro.
Yeah, I pinged the
And it also
name as well.
and it's very important that you understand that it's all start with the concept of solid, right? So everything has evolved beyond solid and interface segregation and separation of concern. It was initially people were talking a lot of separation of concern in the monolith, and it was never happening. So slowly it evolved, and then microservice came into the picture. So if you understand solid religiously, it will not be able you will not be have difficulty understanding microservice, and then all those patterns that we read in the beginning, all the design pattern, everything is implemented. It's just that the now it was more like everything was done in the same machine or on a different way. If you start thinking it a little wider, connecting the dots through services, you'll be able to see that, oh, it's the same thing happening, but it's going little haywire in a different way. Centralized locks, fault tolerance, a lot of things will come because there are multiple nodes, multiple services talking to each other. There are multiple issues that are going to come, and then you have to resolve that out. And to resolve that out, you need to have many things automated. And that's why Siri said that it's more
Yeah,
like if you don't have the capability of doing microservice and you still start doing it, then it becomes a more boring kind of thing than a big fun. Obviously, it's a big fun when you deal with the mess. Yeah. Any other question?
yeah.
Okay, so I think it's
Thank
already too late.
you so
Anyone
much.
who didn't hear
Thank you
the,
so much, Anjali and Sri.
yeah, thanks a lot. Anyone who didn't hear the code, they can type MCS and they will get the certificate signed by Siri, me, and my partner. Thank you very much.
Thank
Thank you. Thank you,
Thank
thanks
Siri,
you.
Sekhar,
everyone.
Good
for your
night.
time.
Thanks.
Yeah,
Good night.
thanks. Thanks,
Thanks, Shri.
everyone. Bye bye.
Bye.